Hello, OWL sophomores. I am Mrs. Myers, and today we're going to be doing an ACT science passage. This is the passage that you're going to be working with today. It's from the September 2023 test, so pretty recent. And this is a pure data passage. What that means is they're just going to give you a lot of data and you answer questions about the data. Couple tips for this passage. I probably wouldn't read these sections here unless you can't find your answer anywhere else. This picture might be helpful. You can see they're going to have gas in some kind of container and a piston, this like stopper that can go up and down according to these arrows. And then you can see you've got 4 different tables. I might circle the titles of these tables so I can find them quickly when I'm going through the questions. You can see for each table, they keep some things constant. So like table 1, volume and temperature were constant. Table 2, the amount of atoms and the temperature were constant. Table 3, the amount and the pressure were constant. And table 4, the amount and volume were constant. And then they did a whole bunch of trials, 19 different trials, and they measured different things with each trial, okay? Finding which part of the passage for each question is pretty easy for this one. You can see 30 and 31 ask about table 1, and they just tell you table 1. You can see table 2 is number 29. They tell you table 2. You can see 32 is asking about trials 8 and 15. So you'll find 15 here, and you'll find 8 here, okay? And then you can see that this one's asking about 15 through 19, so that would be table 4. The only one that's a little bit tricky is 33. This one has the piston locked in place, so that means that the volume would not change, and we'll get to that question eventually. All right, let's try these. Try question 29. All right, 29 says a student claimed that for a given amount of gas, okay, so the amount is constant, at a constant temperature, all right, temperature is constant, decreasing the volume of the gas would increase the rate of collisions. So as volume goes down, what happens to the rate of collisions, okay? I don't see anything about collisions here, but I do see that pressure is here. And you would think that there'd be more collisions at a higher pressure, okay? And so it looks like as volume goes down, pressure goes up. You can see it goes from 0.25 to 1.5. So the answer for 29 should be A. Yes, as the volume goes down, the pressure went up. As this one goes down, this one goes up. All right, try question 30. Question 30 says, according to table 1, so we're on table 1, as the number of atoms increased, so as we go up in the number of atoms, the pressure of the gas, what happens here? It looks like this guy also increases, goes from 2 to 8, okay, as we go down these columns. So the answer for 30 should be H, increased only. All right, try question 31. Question 31 says, we're looking at table 1, so we know we're looking at table 1 here. Consider the data in the table for 2 samples of gas. The volume here is 3. Here our volume is 0.4. However, you can see they have the same volume, just like all of these have the same volume. The temperature is 50, which is a different temperature than here, but you can see the temperature is the same for both, just like all of these trials have the same temperature. But the pressure is different. For sample 1, the pressure is 4, and for sample 2, the pressure is 8, okay? And they say, based on this, how do the masses of the samples compare? Okay, I don't see anything about mass here, but I do see amount, okay? And you'd think for a higher amount, you'll have also a higher mass, okay? So now we just need to figure out, based on our table 1, as the pressure goes up, what happens to the amount? And it looks like the amount also goes up, okay? All right, so sample 1 has a lower pressure. That tells me he'll probably also have a lower amount, okay? So the answer for 31 should be D. He'll be smaller because he'll be made of fewer atoms. If the pressure was lower, like here, on this end of the table, the amount would also be lower, and so he would have a smaller mass as well. All right, try question 32. Question 32 asks about trials 8 and 15. So here's trial 8. And here's trial 15. So we're going to have to use both tables 2 and tables 4. Okay, and they ask which one best is the best diagram to represent them. Okay, we don't see anything about like amount of atoms or pressure or temperature in the pictures, right? The picture pretty much just shows volume. Okay, so let's focus on volume. The volume for trial 8 is 1. And volume, we don't see it here, but we do see it up here. The volume for trial 15 is also 1. So if they had equal volumes, the picture that would best show that would be F. 32, you can see that you have the equal volumes here. There's the same volume as that. All right, volume means like how much space something takes up. All right, let's try number 33. 33 says the piston was locked in place. Okay, if we go back to that picture that we just had on the previous one, the piston is this thing in the middle that could go up or down, okay? If the piston's locked in place, it's not going up and down. It's going to be at a constant volume, okay? The space it takes up will be constant. So we're looking for where the volume would be constant because the piston is locked in place. So here, table 1, volume is constant. All right, here, table 2, volume changes, so it can't be table 2. Here in table 3, volume changes, so it can't be table 3. And here at table 4, the volume is constant. So our answer for 33 should be 1 and 4. Answer B. Okay. Try our last question, question 34. 34 asks about trials 15 through 19. So I know I'm looking at table 4, that's trials 15 through 19. And they say, how were the volume of the gas and the average speed of the gas affected? All right, volume we see in table 4 was constant. It's going to have to either be H or J for volume. Okay, it stayed constant. They're both at 1 liter for volume. And then average speed. I don't see anything about speed here. However, I do see temperature, okay? If you know from chemistry or physics, as things heat up, the molecules move faster, right? Warmer things, molecules move faster at. So as we went up in temperature, the average speed of the atoms should have increased. So our answer for 34 is H. All right, thanks for watching, guys. Have a great day.